Hi, I'm Rob Jacob from Tufts University, and I'm the moderator for this talk. And I want to introduce the three guest editors of this special issue of IEEE Computer on physiological computing. They are Giulio Iacucci. And Giulio, tell us where you're from and a little bit about yourself.
Yes, I'm Italian, but I work at the University of Helsinki primarily. And basically my research group focuses on a variety of new interaction techniques, including multimodality, always trying to push user interfaces beyond what we encounter every day.
Good, thanks. The other two special issue editors are Steve Fairclough. Steve?
Okay, hi, I'm Stephen Fairclough. I'm a professor of psychophysiology at Liverpool John Moores University in the UK. So I have a background in psychophysiology and neuroscience, so I'm interested in applying those techniques to advanced human-computer interaction.
Thanks. And Erin Solovey.
Hi, I'm Erin Solovey. I'm an assistant professor of computer science at Drexel University, and I direct the Advanced Interaction Research Lab there, where we do a lot of research on novel input and output devices, and specifically we've had a focus on brain-computer interfaces and physiological computing.
Thanks. So I think this is the first special issue of any general readership computer journal or magazine on physiological computing. So I wanted to ask you folks why? Why now? What's happening to this field that's making it suddenly take off? Why did you decide to edit?
If I can start, but I'd like the co-editors to contribute also on this question, is basically we have seen lately some applications of physiological computing, some very simple application find their way even to smartphones outside what used to be more specific areas like sport. And this, alongside with this kind of attempts to introduce this kind of tools to wider consumer electronics, there has been lately a lot of advances, and more research groups are studying physiological computing from different disciplines.
Okay, well, from my point of view, my point of view, I think there's a kind of technological imperative where we're seeing more and more sensor technology that is designed to measure the body and the brain being developed and being made available, as Giulio says, as part of smartphones and other things. And really what you've got is a creep of data that was formerly used for exercise, monitoring exercise, and then for monitoring health. And now I think is a good time to think about what are the other ways in which we can use it? How can we use these sensors and the available data in order to create new kinds of interactions and new kinds of intelligent interactions with technology?
Erin, anything?
Right, and to build on what they've both been saying, we have seen this increase in the availability of sensors, and they're becoming less expensive and things like that. At the same time, our computers, we're carrying them in our pockets. We have computers everywhere with this processing power, and we also have more and more demands on us. Like we're always multitasking, information overload, and I think people are looking for better ways to mitigate some of this, and we're constantly giving off this physiological information automatically without any extra effort. And if we could start to pick that up and use that to have the systems that we're working with adapt and support us, then we can have a better user experience and be able to handle some of the different tasks that we're doing in a better way.
Mm-hmm. So where do you think physiological computing is going? It seems to me one possibility is that it's going to become a special purpose or niche area. It's used for fitness or for gaming or something like that. Or the other end of the extreme is it will be part of every user interface. Like you would be crazy not to sit down and plug in your wristband or something. Or somewhere in between. Where do you think it's heading?
Yes, if I can start, we have seen how it could be applied successfully in some very specific area, namely sport from one point of view, but also accessibility for people with disabilities. And we think that the use of these more and more available sensors and techniques to analyze the data will make a new application possible for a much wider group of users. For example, we are working on ways to improve information retrieval to physiological computing.
Well, what I think is that the technology will become more ubiquitous in a broader sort of sense. Because really what you've got, as Erin's already said, is data that is being emitted by the person continuously and implicitly without the person having to do anything extra. And what I've argued before is that if we can harness that technology, that sort of sensoring capability, to represent the psychological or behavioral state of the user, then we can make technology aware of that, of the state of the user, in order to enable, I guess, what you would call smarter technology, or technology that is at least aware of context and that is able to act on that context. So I see it as something that's quite niche at the moment, so sports and people with disabilities using brain-computer interfaces. But I see a broader spectrum of approaches where we're able to monitor the psychological state of the person and to use that psychological state to leverage all kinds of intelligent adaptation.
Erin?
Yeah, and I would just say, this, as in the articles that are in the special issue, we'll see that we're using this physiological information to augment the interactions that people are having, and this can come into play in lots of domains. Some that are safety critical. So if you have people who are doing safety critical tasks, and we can also detect just without any extra effort from them that they're getting stressed or something like that, then we can have the system adapt. And so some of these domains, and then you could look at things like education, which is something we've been looking at, and see if we can understand more about what's going on as you learn information. And so I think as the technology becomes less expensive and more comfortable to wear and things like that, we'll start seeing it get deployed in many, many areas.
Yes, I'm going to violently agree with you and Steve and answer my own question that it seems like in the long run, as this stuff gets cheaper and easier to use, it's an extra source of information about the user that the computer can get for free. And it's plausible that in the long run, it'll be part of every user interface. Just like any desktop interface involves a mouse, perhaps it'll also involve a little bit of gadgetry. What do you think the most pressing technical issues are in this field? And I'm going to separate the two questions. The next question I'm going to ask you is, what do you think the key scientific questions are? You can answer them both, or we can do them in two. What does the technology need, and what are the scientific issues, do you think?
Yeah, I think looking at some of the application we have shown that in principle it's possible to detect certain states, and so theoretically things work. But as soon as we go maybe in more realistic settings, the robustness might fail and make the thing impractical still, which might be due to the quality of the data or the ways we analyze it and ways to deal with the noise and so on. But this varies drastically from application area to application area, I would say. And this is for my part.
Mm-hmm.
I would say that if far as the technical challenge goes, it's in the area of sensing, and it's in the area of unobtrusive sensing, in producing sensors that deliver robust data, that is sensitive data, with a minimum of intrusiveness for the user. So, for example, the systems such as like the Kinect camera that look at heart rate and so on using a camera, using a non-contact method, are ideal in some ways, but obviously in other ways they can be problematic. So I think getting around that issue where we're getting good quality data without inconveniencing the user is the biggest technical challenge facing the area at the moment.
I would agree with that. The technical challenges of getting a robust signal are extremely important and have to be they're a requirement for this whole field to move forward at all. If we're not getting a robust signal, then we can't move forward. But I also think that there's a pretty big challenge on the application and user experience side as well, which is figuring out, once we have a robust signal, how to use it effectively, because it is a different type of signal than we're used to, a different way of interacting. It's different from how we traditionally interact with a computer, where we explicitly give a command, so we click on a mouse or touch the screen, and now we're getting these implicit signals from someone. And so the way that we use it to adapt a system is going to also be challenging to figure out the best way so that people actually see the value of using this type of input.
Yeah, I agree with you, Erin, not surprisingly. I think a big challenge here is how to use this kind of non-intentional input. That's just not what interfaces have been designed for in the past. So let me go back around and ask you about the scientific questions. What scientific issues do you think this field should tackle? I mean, it's been sort of a technology push, a bottom-up kind of field initially, but someday we'd like to become a real science.
I just think that, for me, is that a lot of the approaches that we're using, and the measurement techniques and the methodologies, originated in psychology labs. And Julio and Erin have both referred to this in their answers. They've originated in highly controlled environment where it is relatively easy to make inferences about a person's psychological state or behavioral state based on the signals, based on the physiological activity or brain activity, simply because you know how other variables are kind of controlled. So I think one scientific challenge is that in my discipline, in psychology, we bring people into laboratories and we do all kinds of things with them. We get them to do tasks that are mentally challenging. We provoke emotional states in them. We induce stress in people, and we do all of those things. But scientifically, we have to sometimes ask ourselves, are we getting the genuine article? Is this really what stress looks like for this person? Is this really what anger looks like for this person? So part of the scientific challenge for us, I think, is to take these methods and methodologies out into the field and to record data from large groups of people and to really try and measure psychological events and emotions and the types of things that we're interested in the field in a real-world setting, and getting data that we probably have more confidence in because it's got a greater level of ecological validity. So from a psychologist's point of view, that's one big kind of scientific challenge, I think.
What do you think the applications are for this field? And let me put it in two parts. In the short term, what are the first places we'll see this in use? Obviously, fitness is already happening. And what do you see the applications in the longer term for physiological computing?
Well, I think that there are a number of, let's say, application fields that would greatly benefit from this kind of sensors. And I think if we look at some application fields that have the ability to bring in such type of innovation quickly, I'm thinking of the automotive industry. They already have been able to integrate a lot of sensor systems that allow to, for example, understand if a driver is tired. And I think some of these application fields that really push technology into the everyday world will be the first ones. Although, as we have seen with the smartphone examples of stress detection applications, sometimes they don't very much make sense practically, even if we push them. But apart from this, I think that there are a variety of other applications that we have not, that is part of our research process to explore. So in the human-computer interaction field, a lot of the research is spent also in investigating new application fields. And for example, I was mentioning before the problem of information retrieval that could be expanded into something more like thinking of how implicit channels help us navigate the too much information we are exposed to every day.
Well, yeah, we've mentioned a few different applications already, and I think we'll continue to see it expand. But, Julio mentioned driving and measuring. You can measure things like fatigue or stress and things like that. And as cars become more autonomous and things like that, might be good to have some idea of how the human is doing in the loop and let the autonomy pick up as needed. But also, I had mentioned looking at people who are learning and understanding physiological processes that are happening that might help us understand better and predict whether they have learned something or understand it, both in traditional education, but also in training situations. So, have they reached a level of expertise yet or not? And then have the educational system that they're using adapt to present appropriate learning or training information as they go through the process. And then we've already also seen it in things like usability testing for different applications in video games or other anything that the user experience depends on more than just whether someone does something quickly and makes very few errors, but where there's more components of it, like are they enjoying it, are they getting bored, are they getting stressed, are they scared? So those types of things we're already starting to see happen. And I think these are just a couple of examples, but there's going to be many more.
Julio and Aaron are both pointing out there's two big areas. One, safety critical performance, and the need to monitor the person in that sense. And in the education example, it's about the pace and the setting of demand of information and managing to tailor that to the person. So you're really talking about something quite radical, which is a system that adapts, say, the delivery of information to the needs of a specific individual at a particular time. So it's a really wonderful example, I think, of really fitting the task to the person. I think another kind of area that I've been involved in is using these measures in I guess more of a kind of an entertainment or an infotainment sort of setting. So we've looked at things like measuring people's level of interest when they're in a cultural heritage setting, so that the type of information you get if you go into a museum or an art gallery is tailored to the types of things that pique your interest, that are of interest to you. And that can kind of roll out into things like media tagging, so like tagging items on Amazon or tagging tunes on iTunes and so on. So there is, as well as gaming, which is the obvious place where all of this kind of technology started, I guess, in some ways, there's all kinds of other things that to do with how we process information and how we tag information for our own entertainment.
So last question I wanted to ask you is, where should readers go next? If they found this field interesting, what else should they look at? Are there conferences or journals they should look at? And another question is, where should a new researcher go who wants to join into this field? And I'm figuring, Steve, you have a very good answer to this question.
Yeah, I do, yeah. We put a book out by Springer, on Springer last year, called Advances in Physiological Computing, which I think was the first collection of this area. And we did sort of write that we did kind of put that together with the intention of someone who is new to the area. So there's not just specific chapters, including like one by Erin and other people on specific applications, but also there's some stuff about the background, about where this area developed from, and some material on the development of signals and algorithms that are used specifically in this area. So that would be my recommendation for a new person.
You also helped start an annual conference in this area.
There is an annual conference. We're in the third year of Physiological Computing Conference, which will be in Lisbon next June, if my memory serves correctly. But that's called the Physiological Computing Conference. I think it's called PHYCS. If you look it up, I think that's what it's listed as on the internet. So that's entering into its third year now. But obviously, as you know, there are other conferences that sometimes have papers on this included as well.
Anyone else have suggestions for where the readers should go next?
The readers are going to have broad interest, and so there's definitely, because this is a very interdisciplinary topic where there's work being done that relates to this in things like signal processing and really more on hardware. And then there's other areas that focus more on applications and questions about the human-computer interaction. So, there's been, for now, some years, a lot of papers in the CHI conference, which is the main human-computer interaction conference, as well as sometimes there have been workshops that are held at CHI or at other similar conferences. I know, Julio, you probably want to mention the Symbiotic.
Yeah, there are a variety, yes, of workshops that are specialized, like the Symbiotic Interaction workshop. But yes, indeed, there are also the different user interfaces conferences, such as the UIST, so Software and Technology Conference, and the Intelligent User Interfaces Conference, like several places. Yeah.
Mm-hmm. Yeah, I guess augmented human also is covers this field sometimes. Yeah. Good. All right. Well, let me thank you all very much. Congratulations on putting this special issue together, and look forward to seeing this field move on and flourish.
Thanks very much, Rob.
Thank you.
Okay, thank you.
Thank you.